Database is the most crucial part of your application as it helps you to store the information about your application users. Now imagine you launched a product in the market and users start registering with your application. Now as soon as your application becomes popular and your database is flooding with the millions of users of data, then the actual problem starts. Your database will become a performance bottleneck and your users will start facing the latency, request timeouts and lots of other issues, which will eventually convert it into a financial loss. Now to mitigate these issues, I am going to show you a powerful database query technique which will significantly help you to increase the database performance. So let's jump into the practical video demonstration. Now before jumping directly into the practical demonstration, I want to show you that what kind of data I have in my database. Here I have opened MongoDB Compass and I have one database named as my_product. And in this database, I have one collection named as users which have 1.3 millions of users data, which is obviously a fake data, but I have added this for the demonstration purpose so that I can present you the real practical scenario in front of you. Now here I am using MongoDB, but in your product there can be another database, like it can be a Postgres or it can be a MySQL. But trust me, this thing doesn't matter because our ultimate goal is to improve the query performance of our request. So now let me do one thing. Let me just go to the Postman, and here I have one API named as fetch users, which is basically doing the user fetching task. So it will help me to fetch the users data from the database collection, and it is pretty common API which we almost implement in each and every application. So let me just fetch the data from this API call. So now as soon as I did the API call, here I am getting some information from the database. So what I get in the meta information is I am querying the page number 1, and after applying the pagination logic, what I get is the data can be segmented into 13,080 pages, and the amount of data which currently I am getting is about 100 documents. So here I am applying the offset based pagination, which is helping me to get the segmented data from my database so that my users will get the smooth experience and they can switch between the multiple pages. Now if you can see over here, the amount of time this database query take is around 1.08 seconds. But what if I change this page number to page number 10 and then I send the query? So now see, the amount of time it took is around 1.06 seconds. What if I increase the page number to 100? Now let me just send it again, and now just see, the amount of time it is taking is again 1.06 seconds. Let me just increase it to 1000, send it again. Now the amount of time it is taking is around 1.17 seconds. Let me just increase it to now 10,000, and now you will see major difference. So let me just click again, and now you can see over here it is taking now 1.99 seconds, which is almost 2 seconds. And if I go to the last page, which is 13,080, so it is now taking 2.37 seconds. That means if I increase the page number, then here the database is taking longer time to fetch the data, and this will end up with a result in a higher latency. Now you might be wondering that why such thing is happening. So this kind of thing is happening because here we are using a offset based pagination. So now what is this offset based pagination is? So let me just go to the code and show you the code that this API is using. So here I have a code of a API which is using the offset based pagination. So here what I did is basically I have taken the two query parameters and I am passing it to a number. Now here look at this query. Here what I did is basically I am just creating one formula of skipping some amount of document. Let's say my page number is 1. So what I did is 1 minus 1 into limit is basically 100. So this will end up with a 0. So if I do the page number 1 query, then it will skip the 0 number of document, which is fine. But let's say if I am using the page number 1000 and here I am going to subtract one number from it and I will multiply it with the 100, which will give me the 900 number. So here what database will do is it will first keep the 900 documents from my database and then it will return me the 100 next document. And whenever this page number is increasing, let's say it become a 10,000, so give me a number of 9900, and this amount of data first I have to skip from the database and then it will give me the expected results. So this skipping part of the document is the time taking process for the database, and that's why we are getting the increasing latency in the API call. Now to solve this problem, we have another query technique which we know as cursor based pagination. So let me do one thing, just go to the Postman and we are going to change this API call little bit so that we will get the cursor based pagination response. And for that, firstly we have to do some changes in the code. So I will just comment this code and I will just comment one more thing over here, that this code is for the offset based pagination. Now let me just scroll below, and here I have one more code which is for the cursor based pagination. Now here what I am going to do is, let me just go to the Postman, and here we have to do some changes. So first of all, what I'll do, I'll simply remove this page query parameter from here because that is not needed in this current technique. And now I will click on the send button. Now here as you can see, we are getting the next cursor and previous cursor in our response. Also the amount of data that we are receiving is also 100. So what is this? So let me just show you that what we are getting. So if you can just see the data over here, so the first user is a Morna. So let me just check into the database that whether the user is Morna or not. So here we can see the user is a Morna. Here we got some meta information which is direction and the next cursor. So what I will do over here, I will simply put a direction here and then I will put next in this, and then the next key is cursor. So in this cursor I will put the address of this cursor which I get in the response, and I will simply paste it here. Now let me just send the API call, and now see the response, it is around 20 milliseconds. Now here to give you the major difference that we are getting in the performance, what I will do, I will just keep documents from here. Let me just keep 1 million document from here, and then I will do copy of this document which is of the Tara, and then I will just put it over here in the next cursor. So I have just pasted it here, and now let me just click on the send. So as soon as I clicked on the send, I got the immediate response, and which took around 23 milliseconds. And now if we just scroll below, so I am getting the TAD user data. So if we just see over here, the next data is about the TAD and which we are getting. So from this document we are getting the 100 documents data, but the amount of time it is taking is around 23 milliseconds only. So here what is happening? So just think about a moment that what actually we are doing, what this cursor is about and what this direction is. So basically what we are doing is we are directly fetching the data using the underscore ID of the user. So here the next is directing API call to fetch the next 100 records from the given user ID, and that ID is we are putting into the cursor. So cursor is basically a starting point of your data from where we want to fetch the 100 documents. So here the major difference between the offset based pagination and the cursor based pagination is we are removing the skip element from the pagination and we are putting the direct address of the document from where we want to get the data. That's why we are able to fetch this data immediately on a very minimal time. So this is just about a 1.3 million data, but even if you have 100 million of data, I can say that this cursor based pagination will help you to boost your database query very significantly, which offset based pagination can never do. So here let me just show you the code as well. So here we are basically fetching the query and here we are applying the cursor. So if you see over here, I have added one condition. If direction is next, then I will find the ID which is greater than the given ID. So in MongoDB, these IDs are also variable so that we can also apply some operators over here, and we can also do this thing in other database as well. Those database also support this kind of operations. Now we are doing the same thing for the previous as well. So if you change this direction to previous, then also it will work, but in a previous direction. And here if you see over here, there is no skip element. We are just sorting the data and here applying the limit. This is very simple implementation of the cursor based pagination which will help us to fetch the data from the database. So this was all about this video, and I hope you got the idea how you can improve your database performance using the cursor based pagination. And with this video, I didn't mean that offset based pagination is bad, but that totally depends on the usage of your application and the amount of data your application is currently having. So that totally up to you that which kind of pagination technique you have to apply for your data. Now let me just conclude this video, and if you enjoyed this video, please press the like button and drop one comment so that YouTube can recommend this video to more and more people. So now thank you for watching this video and I will see you in the next